All right, so in that bottle, as soon as you open it up, what do you observe? Bubbles, right? That means that the CO2 is coming out of solution. So the more pressure, now here's the key is you have to have CO2 above it. They used to come out and say you could just have this pump and pump it up and put the pressure in there, but that's putting air. Okay? That's air, and that's not going to increase the CO2. It's got to be the same gas you're trying to dissolve. Okay? But the greater the pressure, there's about 5 atmospheres of pressure on a bottle of soda or in a can of soda. Okay? And when it goes down to 1 atmosphere, that means it's direct proportion. That means now the solubility is 1/5 what it was before. Okay? Directly proportional. Now you're not going to do any math with this. You just know that increased pressure means increased solubility. So, you read the article, I'm sure, on scuba diving.
Yes.
What happens when you get the bends? You come up too fast.
The nitrogen in your blood boils.
Nitrogen boils because it's just like opening the bottle of soda, is that all of a sudden now the pressure is decreased. So you're down at 50, 75, 100 feet. Does anybody know how many feet it is for every atmosphere of pressure?
I think it's like 10 meters.
10 meters, like 33 feet. That's exactly right. Okay? So about every 30, 33 feet you go down, you've doubled. You've gone from 1 atmosphere of pressure to 2. That's why your ears start popping and hurting and all that, because the pressure is getting so great. So if you're down at 30 meters, nearly 100 feet, you've got 3 times the amount of pressure. Well, actually 4 times, because you have 1 atmosphere and then another 3. Okay? But you're 3 times more pressure. That means you have 3 times more gas dissolved in your blood as you're breathing. Okay? And so as a result, now you see a shark. You say, oh crap. Ah! And you go flying to the top. Well, now all of a sudden you reduce that pressure again real fast. Now, why does the oxygen not be as big of a deal as the nitrogen? Think about it logically. Because you're breathing in not basically nitrogen and oxygen. That's 99% of all the gas that you're breathing in is nitrogen and oxygen.
Because you're using oxygen.
Because you're using the oxygen, and so your body's getting rid of the oxygen kind of on its own fast. But the nitrogen is just there. And so it tends to bubble and collect in your joints and cause extreme pain. So does it say in the article, I can't remember what they do to help correct it, treat it? I don't think it said anything. They put you back in a barometric pressure chamber. They repressurize you. Because what's that going to do? It's going to push it back into your dissolved, and then they lower the pressure slowly. So, I am not scuba certified. It is a bucket list of mine. Okay, I want to go scuba diving in the Caribbean or somewhere where I feel like I'm in a big aquarium. Okay, I've snorkeled, but that's a pain because constantly getting water in the snorkel and you can't go under anyway. But I've been told when you go down, based upon how deep you are and how many minutes you're down there, then there's a chart saying, okay, well you got to come up 10 feet and stay there for 5 minutes. Then you got to come up another 10 feet and stay there for another 5 minutes and just keep adjusting all the way up, come up slowly, so your body has a chance to get rid of all that dissolved gas. Okay? So Henry's law is very practical to us, even though we didn't know what it was, is that this is what keeps our sodas fizzy and what keeps us from getting the bends when we scuba dive. Have anybody ever been scuba diving? Have you?
Yeah.
Wow, it's pretty cool, isn't it?
We actually saw a shark.
All right. Was it scary? Was that scary?
No,
The shark means
it didn't really help when my nose bled.
No, that's probably because of the pressure on that too. Okay? Now, all that's left in the notes are a set of miscellaneous terms. Okay? And my notes that were up here are no longer up here either. Okay? So miscellaneous terms, I can pull that up though. So this is just a vocab lesson. did post it, right? Didn't I? And that's how you have
You
it, right?
dive from this thing.
You can, like, if you're deep enough underwater, usually.
Yeah, I mean, I wanna scuba dive, but I'm not sure I wanna see a shark.
They're pretty chill. Yeah, I follow my bear.
You just gotta kind of push them over.
Oh, yeah. Well, if you turn them on their back, I heard that they kinda go, oh shoot, I gotta do that too.
Well,
You
usually,
just punch them in the nose.
well, they usually will only go after you if you're at the surface, cause you'll look like a turtle or a seal.
No,
If you're underwater, you look weird to them, so they punch you.
punch them in the nose.
I mean, who's
That's what I
going
would
to
do.
win in that situation, a punch or a big shark?
Yeah, the thing is, you can't punch it very hard because you won't move through the water.
Yeah.
So you just gotta
I
go on
defy
and go with it. Right.
All right, I'm not gonna get to miscellaneous terms. Now, by the way, on Monday and Tuesday, so it'll be Tuesday for y'all, we're gonna do another lab, okay? This is called Beer's Law Lab. I figured this is a college prep class, and so we need to learn Beer's Law, okay? Has absolutely nothing to do with beer, though. Yeah, I think the person's name that came up with this his last name was Beer. Okay? But it's gonna be about making solutions of different concentrations and practicing doing that, and then measuring with a visible light spectrophotometer. We're gonna measure the absorbance of the light through a solution, okay? So the hardest part of this is going to be making the solutions. Did it really, I turned it on. Okay, real fast though. And again, everything that we talked about today is in the notes that I posted online for you. I do think it's better for you to write it down. But how do we make something dissolve faster? Not more of it, just faster. Heat it up, right? It's gonna dissolve faster. Why is it dissolving faster if you heat it up? Okay, you gotta speak up. They're moving more. What has to happen with solute and solvent in order for them to dissolve? Well, even simpler than that. Oops. I don't have time to ask questions. They gotta touch. In order for the bonds that are very short term, so they have to touch in order for them to be able to dissolve. So heating them up moves them faster, so they touch more. How else do we make it? Stir the solution, right? So if you wanted to get that sugar to dissolve, you stir it, because if it's just sitting at the bottom, only the ones on the bottom and the water at the bottom are touching. You stir it up, then more water molecules are touching the solute particles, and it dissolves faster. And then what does crushing it do? More surface area, so again, more touching. The whole key to get something to dissolve faster is make solute and solvent touch. Okay? Alright, well you guys have a great weekend. I'll send a reminder out, but feel free to send your own reminder to wear proper lab clothes on Tuesday.